So for 2.2, we're going to start off with graphing piecewise functions. When you do these, the easiest thing to do is make yourself function tables. Look at the inequality, pick your x values based off of that inequality. So if you look at this example, you have f of x is equal to x squared if x is less than or equal to 1, as well as f of x is equal to 2x plus 1 if x is greater than 1. So with both of these functions, you're going to use 1. The only difference with them is that the first one, that x squared if x is less than or equal to 1, you're going to have a closed circle on that 1. If you're just greater than 1, like on that bottom one, it's going to be an open circle. So if you look at this, again, we're going to just do a function table. If it's telling you that for the x squared, your x values are less than or equal to 1, what are numbers less than or equal to 1?
0.
What else?
1.
Okay, what else? Anything else you want to try? Less than or equal to 1. I would do -2, at least 3 or 4 points, or 3 or 4 x values. If you plug the 1 in, the 1 squared is 1, so that gives you the ordered pair 1, 1. For 0, the 0 squared is 0, so that's the ordered pair 0, 0. For the -1, -1 squared is +1, so that's the ordered pair -1, 1. And then for -2, the -2 squared is 4, so that's -2, 4. If you were to graph these, you're less than or equal to 1. So this 1, 1 is going to have a closed circle on your coordinate plane. So we're going to start at 1, 1. That is here. Then we have 0, 0, which is here. Then -1, 1, and -2, 4. If you were to do 3, -3, it would also be 9. So -3, 9 would be 4, 5, 6, 7, 8, 9 here. So your line would start at that far right point and just curve and go up to the left. So this would be part of a parabola. Remember, those parabola functions look like a U. If you used the 2x plus 1 to find your y values, and your x is greater than 1, you're still going to use this 1, but this 1 is going to be an open circle. What are other numbers that are greater than 1? 2, 3, 4. So if we plug the 1 in, 2 times 1 plus 1 is 3. So that's the ordered pair 1, 3. Again, that's going to be open. For the 2, that's 2 times 2 plus 1. So 2 times 2 is 4, plus 1 is 5. So that's the ordered pair 2, 5. For 3, 2 times 3 is 6, plus 1 is 7. So that's 3, 7. And lastly, the 2 times 4 is 8, plus 1 is 9. So that's 4, 9. So again, we said that 1, 3 is going to be an open circle. So 1, 3 is here. Then you have 2, 5. 2, 1, 2, 3, 4, 5. Then 3, 7. And 4, 9. So we're going to start at that open circle and go to the right and up. So you'll see with these piecewise functions that from the left to the right on the coordinate plane, it's covered completely. You're going to start with one function. It's going to go to one specific x value and stop there. The next function will pick up at that x value and then continue to go to the right. Sometimes you're going to have more than one or more than two functions in a piecewise function. Piecewise, think about the way it sounds. Piece, part of. You're just putting a bunch of parts together in order to cover the entire coordinate plane. If you look at the next question. For this one, you have three functions that you're working with. You have that f of x is equal to negative 4x plus 3 if x is less than negative 1. F of x is equal to 1/2 x minus 1 if if negative 1 is less than x, which is less than or equal to 3. And f of x is equal to 3 if x is greater than or equal to 3. Change this around a little bit. I want to do it to where your open circle or your open close kind of circle things are right. So change that 3 in the middle to just be less than 3. And then change the negative 1 to be less than or equal to. That's your y value for any x value that's greater than or equal to 3. Okay, so if we do function tables, we're going to start with the first one. You're going to have your x values. You're going to have the negative 4x plus 3, and you'll find for y. Your x values, it tells you that x is less than negative 1. So start at negative 1, go less than negative 1. What are other numbers that are less than negative 1? Negative 2, negative 3, negative 4. Again, I would do at least 4 points, or 4 x values. If we plug these x values in and solve for y, this negative 1 is going to give us negative 4 times negative 1, which is positive 4, plus 3 is 7. So that's the ordered pair, negative 1, 7. What kind of circle is going to be here? What's our sign? It's just less than, so is it going to be a closed or an open? It's open because it's not equal to. Okay. For the negative 2, that's going to give us negative 4 times negative 2, which is 8, plus 3 is 11. So that's negative 2, comma, 11. For the negative 3, that's negative 4 times negative 3, which is positive 12, plus 3 is 15. So that's negative 3, 15. And then for the negative 4, that's negative 4 times negative 4, which is 16, plus 3 is 19. If you were to graph these points, start at the negative 1, 7. Make sure that there's an open circle there. Then you go negative 2, 11, which would be about here. We're off the coordinate plane from there, so I'm just going to take that circle, that open circle, and draw my line up through that next point, so I know where it's going to. You'll see with this one, as it goes to as it goes up, it continues to go to the left. It goes at a very slow, it has a slow slope to where it's like narrow, but it will eventually cover the entire coordinate plane as it goes up. Your next function that you have there is f of x is equal to 1/2 x minus 1 if negative 1 is less than or equal to x, which is less than 3. So if we are to use 1/2 x minus 1, and our x values are from negative 1, which is less than or equal to x, which is less than 3. What are the x values that are between negative 1 and 3, including negative 1? Negative 1, 0, 2, and 3, right? Okay. What kind of circle is going to be on the negative 1 for the x? Closed. What about on the 3? Open. Okay. If we plug these in, we're going to plug these values in for x, starting with the negative 1. You have 1/2 times negative 1 minus 1. If you want to change that minus 1 into 2 over 2, so that way your denominators are the same, you can do that. So you're going to have 1/2 times negative 1, which is negative 1/2, minus 2 over 2 is going to be negative 3 over 2. Remember, that's negative 1 and 1/2. This gives you the ordered pair negative 1 comma negative 1 and 1/2. For the 0, you have 1/2 times 0 minus 1. 1/2 times 0 is 0, minus 1 is negative 1. So that's 0, negative 1. For the 1, it's 1/2 times 1, which is going to be 1/2, minus 2 over 2, which is negative 1/2. So that's the ordered pair 1 comma negative 1/2. For the 2, it's 1/2 times 2, which is 1, minus 1 is 0. So that gives us, where's it, 2 comma 0. And then for the 3, that's 1/2 times 3 minus 2 over 3, or 2 over 2, sorry. So 3 over 2 minus 2 over 2 is 5 over 2. And again, that one is 2 and 1/2. So that is 3 comma 2 and 1/2. If we were to graph these, remember your first one that you're graphing, that negative 1 and 1/2 is going to be closed. The 3 and 2/2 and is going to be open. So negative 1 and 1/2 is about here, and we said that that is closed. So keep that one closed. Then you have 0, negative 1, 1, 1, negative 1/2, 2, 0, and then 3, 2 and 1/2. 3, no, that's not right, is it? It's 3 over 2 minus 2 over 2, not plus. So this should be 1 over 2. I don't know. So this one, again, this is just 1 over 2. This is just 1 over 2. So 3 1/2 is here. Again, that one is open, so you got to make sure you put an open circle there. So you just connect your lines or your points to form your line. From here, we have f of x is equal to 3 if x is greater than or equal to 3. If x is greater than or equal to 3, your f of x or y is equal to 3. What are numbers that are greater than or equal to 3, starting with 3? 3, 4, 5, 6. If your y is going to just be 3, it's going to be 3 for all of these. So that's going to be the ordered pair of 3. 3, 4, 3, 5, 3, and 6, 3. The x is greater than or equal to 3 gives you the ordered pair 3, 3 as an open or a closed circle. Closed, because it's equal to. So 3, 3, 1, 2, 3 is going to be here. Then we go to the right. The second half of 2.2 goes over telling whether or not a given equation is a function. With these, if you're given ordered pairs, remember your x values cannot repeat. If they repeat, then it's not a function. So if the x values repeat, it's not a function. If you have an equation, your y cannot be raised to an even power, and it cannot be inside the absolute value. So when you're looking at the equations like we're going to do on the next page, if your y is inside the absolute value, automatically, it's not a function. If your y is raised to the power of 2 or the power of 4, the power of 6, automatically, it's not a function. What it said at the very bottom of this page that was highlighted. Y cannot be raised to an even power or in absolute value.
Is there any other ways to be not a function?
If you're given ordered pairs and your x values repeat, then that wouldn't be a function either.
And that's it, that's all three?
Those are the three qualifications of whether or not it's a function.
Okay.
If we look at this set of examples, for example A, you have y minus x squared is equal to 2. This, you can go ahead and solve it for y. The only thing you'd have to do is move the x squared over by adding it to both sides, and that's y is equal to x squared plus 2. So because your y is not raised to a power that's that's even, and it's also not inside the absolute value bars, this one is a function. For example, B, you have x squared plus y squared is equal to 4. Automatically, you see that this y is raised to an even power. So we said that if y is raised to an even power, like 2, 4, 6, 8, it is not a function. So automatically, this one is not a function.
Because you can't isolate y.
You can isolate y, but your y is going to be raised to that power. And when you do that, you're going to take the square root of both sides, which would then be taking the square root of a negative x squared plus 4. So it's not gonna give you something that where your x values would not repeat if you were to graph those. For example, C, you have the absolute value of x plus 3 plus 2y is equal to 0. If you were to take this one and let's just say you were to isolate your y, you can subtract over the absolute value of x plus 3. This would give you 2y is equal to the opposite of the absolute value of x plus 3. Then you can just divide each side by the 2, which would then give you y is equal to the opposite of the absolute value of x plus 3 all over 2. This y is not inside the absolute value, and it's not raised to an even power, so this one is a function as well. For example, D, you have 3y squared minus 2x is equal to 9. This y is raised to the second power. That power is even. You cannot have a y that's raised to an even power and have a function. So this one is not a function. Andrew? If it's y to the third, that's fine. Y to the fifth, that's fine. But anything like y squared, y to the fourth power, y to the sixth power, it would be not a function. With example E, you have the absolute value of x plus y is equal to negative 16. That y is inside the absolute value bars. So because that y is inside the absolute value, automatically, it's not a function.
So if y is an absolute value, it's not a function.
If y is raised to an even power, and if y is inside the absolute value bars, it is not a function. Think about